Okay, so it's our first time opening up Rhino, and in order to learn Rhino, if you're interested, you can go up to the Help menu. I should add that I'm working in the Mac operating system, and if you use the VDI system with the college, you'll likely be working on the PC side. Things are more or less the same, although the setup is different. In particular, O snaps. You'll see my O snaps here on the left, whereas on the PC side they're on the bottom. We'll talk more about that later. So if I head up to the help section, I've been teaching Rhino for a long time, so many versions of Rhino ago. If I went up to Rhinoceros Help, for example, there would be some tutorials in here we could follow specifically that help you make a flashlight and a rubber duck. So these are, making a geometric object and making an organic object. You'll note here in Rhino 6, if I go down to video tutorials and click it, nothing happens. So for whatever reason, they've sort of let those things drop off. If you Google around online, you can find these. So I'll be looking at some older tutorials later and then updating them on the fly to sort of show you how to do them in Rhino 6. But this first one we're just going to do off the top of my head. So the first project we'll do, I call the Blocky Castle. And for any players of Minecraft out there, this should be familiar. You're just going to make little blocks. You're going to move them around relative to each other, and we'll build up a little structure or a castle that way. I really recommend that anyone doing these tutorials uses a 3-button mouse. Doing these things on the trackpad is possible, but often we're going to want to left-click, right-click, and use the little scroll wheel for zooming in and out. So let me just make a block here real quick, and we can start talking about the layout. So over here on the left, sometimes it's across the top. I'm going to click here on box. And you'll notice that we start a dialogue with the computer. So it's going to ask me, where do we want to get started? And if I want to, I could just click out here on the surface, but I can also type things in. So that green and red line we see, that's the intersection of X and Y. So let's make the first corner 0, which will be interpreted as 0, 0, 0 in the coordinate space. And then it's always going to stack X, Y, Z in that order. So X in this case is the red line. So let's say that we want our box to go out 10 units. So I'll type that in. And then it's going to ask for the width. And you can see now we've constrained X to 10. And so now we're just talking about Y. So let's make that 10 again. And now it's going to be asking me about Z. If I wanted to go down, that would be a negative number. So I'll just type in 10 and I'll get that. Okay, so you may have noticed as I was working, even though I only created one box, you can see the box occur in 4 different places, and these are known as viewports. Okay, so this viewport right here, you can see it works kind of like the way the eye sees. So as things travel towards the distance, they tend to, like a railroad track tending towards the distance would appear to converge on a distant point. So that's a perspectival view. But these views over here, these views are known as parallel views, and I have top, front, and right currently. So these are all 4 different views on the same object. However, in this case, parallel lines that travel into the distance do not appear to come together. So the combination of the two makes it easier to see, how does this thing look to the human eye in perspective, but then also in these other views, how do we get really good measurements and arrangements of objects relative to one another without having to wonder if perspective is tricking the eye. So it's important to have multiple viewports, and in some cases to work in perspective, and in some cases to work in parallel views. If I look down here on the right, you can see my layers. So if you've worked in Photoshop, Illustrator, or a similar program, you'll see layers should be kind of familiar. One of the differences is that I have a little check mark here, or a little radio button. So that means that any new geometry is going to land by default onto what in this case is called default. I could change that name to be anything, but what matters is which layer is checked. And then these different layers are associated with different colors, so I can move things between layers, and the color coding will help me remember which layer they belong to. I can lock those layers so they can't be changed. I can change the visibility of the layers, although you'll see that lock and visibility are not available on the default layer. So if I wanted to hide that layer, I'd need to make another layer the default layer. Not in name, of course, but by checking it, and then I can, turn stuff on and off like that. So for right now, we're keeping things simple and just working on a single layer. Okay, at the moment, I'm viewing this cube as a wireframe, right? So I'm just looking at its edges. But if I right-click the viewport title, I can come down here. There's lots of options in here. But the ones I'm interested in are changing from wireframe to shaded, for example, right? So that's going to make things a little bit easier to discern from the background. And then also I could go down to rendered, for example, to give myself a sense of what that looks in a little bit more of a photographic space where it's casting more believable shadows and so forth. And there's other fancy ones you can mess with in here. I mean, some of them you're probably not really ever going to use, like a artistic, which was trying to crash my computer. See, that's not super helpful in this case. So we're probably just going to stick to wireframe, shaded, and rendered as we're working. I usually like to keep my perspective view in rendered or shaded. Okay, in terms of the upper left-hand corner, there's some important stuff to know here. So I have grid snap turned on. Again, if you're on the PC, this might be on the lower part of the screen. So grid snap, like any other program you're familiar with, just snaps the mouse and objects relative to the grid that's laid down in the background. Ortho stands for orthographic, and that will restrict movements to a specific number, generally 90 degrees. Planar means that if you're coming in on the top view, for example, we're going to default to having everything on the same plane. So these two you're not going to worry too much about yet. Smart track I would generally keep off till later. Gumball is interesting. So if I turn on Gumball and I select an object, this gives me a bunch of visual cues, right? So it makes it easier to move something from the perspective view in a very precise way. You can also get in here and mess around with the, I don't really use the gumball that much. I think some of these, like there's scaling commands, there's rotational commands, and so forth. It's something you'll have to play around with to see if you can figure out how to make it work. So I'm going to hit undo for now, turn off the gumball, and then we're also going to leave history alone. Now, if history alone rather. If you're on the PC side, I believe the strip, which you'll find at the bottom, will also have a checkbox for O-snaps. And unlike the kind of world grid snap we're talking about, the O-snap means object relative snaps. And that's going to become important in this little project that we're going to do. So with an O-snap, which I have down over here, right now I have a couple of them turned on. I'm just going to turn them all off temporarily. And I'll leave these at persistent because I want them to happen over and over again. So let's say that we want to take our cube and copy it so that we make a vertical stack. Okay, so the way that we would do that is to type in the word copy. I should say that in Rhino, there's at least 3 ways to find every command. So there's graphical buttons that you can click on. You can go up through the menu and find these commands, and then also you can just type in their name if you happen to know their name. And once you start to learn commands and their names and use them frequently, typing can make you very, very fast in the modeling space. So let's take a look at what the computer is asking us here. It's saying, what's the point to copy from? This confuses a lot of people. So let's say I want to copy from this bottom point to this top point because I want to start stacking the box on top of itself. Okay, so if you have a really distinct corner like that, there's a number of O-snaps that'll work. End is one of those O-snaps, and not. So basically anytime there's a kink in a line or the top of a curve, not would work. There might be some other ones too, but let's just pick end. So I'm going to say I'm going to copy from this end. So you see I get close, and then the O-snap pops up and lets me know that it's firing off. So I left click there, and then the computer prompts and says, what's the point to move to? And at first when I start to lift up, you'll see it kind of moves in this, look at my top view over there on the left. You can see it moves in this strange direction. That's because in perspective, which is not a parallel view, it's a little unclear what I'm talking about as I move the mouse around. And that's why O-snap is so helpful, because it's going to snap it back into place immediately over the top of the original cube. So I'll just left click there. And then I'm zooming in and out right now with the mouse wheel. Now, if I wanted to, I could just continue to use this O-snap and just left click over and over again. But I can also use these fancy little commands here. So the point to copy to, once I've done the first one, I can say from last point, use last distance, and use last direction. And now if I just zoom way out and have my left mouse button and then I go way up in the air, I can go 1, 2, 3, 4, 5. For whatever reason, I have to go a little slower, it looks like. Just do something like that, and when I'm ready to stop copying, I just hit escape. Okay, so that's one quick way to do that. And I suppose what I should also mention now is how I've been moving around this space. So when I take the left mouse button, right, I can click on individual objects and get some information about them. I can also drag a box. So if I drag from the left to the right, I can make a selection box like that. However, if I just partially touch an object, it will not be selected. So that can be useful for picking an object out of a group if you don't want to bring everything with you. If you do want to bring everything and you want to just be kind of sloppy about it, you can drag from right to left, and then anything you touch does become selected. So that's the left mouse button. The right mouse button will change depending on the viewport you're in. So if I hold down the right mouse button, I can orbit around in the perspective view, but you'll see that in a parallel view where we don't have 3 dimensions represented, holding down the right mouse button just pans you around. And I think the pan and the perspective view, maybe I hold down shift in the right mouse button. Yeah, that's correct. The mouse wheel, I can zoom in and I can zoom out like so. And so that's one of the reasons why a right-clicking or a 2-button mouse is really important in the Rhino space. Okay, so we have our vertical stack. I'm going to select that whole thing, and I'm going to look down from the top, and you can see because it's a parallel view, I have no indication that there's multiple boxes here because they're stacked exactly under one another, unlike in a parallel view, or a perspective view, rather. So let's type copy again. The point I'll copy from is the lower left corner, and the point I'll copy to is the lower right corner. And so we move our stack over by one cube unit. And then I select those 3 options and then just keep on left clicking, and I can make a wall like this and hit escape to stop it. So you can see that relatively quickly we can use these commands to get a lot of stuff stacked absolutely perfectly in space, which is something that would otherwise take a long time if you were trying to do this stuff by hand, so to speak. Now let's show you another example here. If I take one of these cubes and I turn off grid snap, I'll turn off planar while I'm at it because we're not really using it. So this is something a lot of people when they're getting started try to do, which is to place this stuff just kind of by eye. So let's say I move this away down here, and then as I move it back I try to get it just exactly right with the mouse. That looks pretty good, right? So I unclick it, everything looks perfectly fine. But if I zoom in, so it looks like I placed it pretty well. Let me tell you though, in almost every case when you're placing things by eye, I see this all the time with students, you get something more like that, and from a distance things are going to look absolutely fine, right? But when you zoom in, if there's little teeny tiny cracks between things, this will cause huge problems later, particularly in the 3D printing space. Okay, so you never want to position stuff casually. You also want to have things, you always want to have things exactly on the money. So let me make sure to, and actually to restore it just to make absolutely sure, I'll just move it a little bit away like this so it's really clear, and then I can type in move, my O snap picks up that, my O snap picks up that, and I've restored this to perfection. Okay, sometimes when you're zooming in and out and rotating things around, you'll see that the center of rotation kind of gets off center. So one of my ways to repair that is to select everything and then to click this little button right here, which is called Zoom Selected. So that's going to recenter everything that's currently highlighted, but it will also recenter the point of rotation. And if I want, I can pick like a sub-object, and then now that's the point of rotation. Okay, so what are some other things I want to set everybody up with here? At this point, we could come in and start to work on our castle. So let's go ahead and take this wall. I might group it, so just type in group and hit enter. And then let's move it around. So I want to take a copy of it and rotate it so that it's pointing out from this wall at 90 degrees. So I'll type in rotate. And this one is awful tricky. I want to have my top view selected, type in rotate, and then I'm going to click here, and this is sort of the axis of rotation, right? So if I imagine a straight line coming directly away from my eye, which forms an axis around which something can rotate, I'm looking down from the top. And now I'm going to add in what you might think of as sort of a lever that you can use to pull this thing around. So you see how over here in the perspective view, I can see how this rotation is going to preview. So let's take my lever and go straight out to the left. And in this case, I will turn on ortho because I want 90 degrees. Straight out to the left and left click. And then as I move up here, pop, it's going to pop into place because it's restricted to orthographic moves. If I were to turn that off, I could get all of the sort of different measurements in there. And if I wanted, I could type in a very specific number of degrees, like 37 or whatever. But ortho is going to give me an easy 90 degrees. Okay, so I rotated it correctly, although I forgot to copy it. So let's hit undo. I'll just right-click to repeat the last command. And I'll check copy this time, which I forgot to do. So center of rotation, point number 1, point number 2, and then enter. And then now I have that wall over there. Because it's grouped, I can just click it anywhere to select it. Now I'll do another command called mirror. And we're making a copy. In this case, I will use the midpoint instead of the end. And so actually 1, 2, 3, 4, 5, 6, 7, 8. Oh, midpoint or end would work fine here because I don't have to wind up in the middle of a block face. So here I make a axis of reflection, for the mirror, and then I get my other wall in over there, and then I can do the same thing right here, right? So I can mirror it, and this time we're going to mirror right here, and I get that in the back. So once you get some of these basic commands, this kind of building actually goes quite fast. If you wanted to, you could take one of these walls and then rotate it up for the ceiling. So here I can move into a different viewport and say rotate. And so here I'll do axis of rotation, point number 1, point number 2, and left click and then enter. And now I'll just have to take this and then sort of move it into place. You can see me trying to casually put it into place, which is not working because snap is not selected. But if I want to be really careful, I would just say move, grab that endpoint, and go over here. I'm missing one row, so now I can ungroup. And then I can come across, and watch this trick. If I left select, drag a box from left to right, I can grab just that row, because dragging from left to right needs to fully encompass an entire group for it to be part of the group. Or you could just pick them out, by hand with your mouse. I'll say copy, point to copy from, point to copy to, enter, and so now we've got our sort of box going on. Now if I Command A for me, or maybe Control A for you, and ungroup, now every single little cube should be in there by itself. They're known as extrusions right now. And now I can just come in here and start to grab them and delete them one at a time. For example, here I might be making like the door to my castle, and then I could move to a different side and make the window, and so on and so forth. So hopefully you get the idea. So through these commands, you should be able to make more complex stuff. If you're interested, you can make like a little spire. You could make a roof at a 45-degree angle by just typing in a different number of degrees in the rotate command. Now is when the creativity takes over. And I know we haven't seen a lot of techniques yet, but this limitation will really help you get used to some fundamentals, which we'll build on after you do this practice assignment.